So I will start by introducing myself. My name is Tina Rogers, and I am the Director of Curriculum for STEM for the Franklin Public Schools. I'm new to the role as of July. I'm happy to be here working with a wonderful community of educators, administrators, and I'm so pleased to have many of our math specialists here joining me this evening to present, co-facilitate with me. And so for those of you that aren't aware of our structure, we have 5 middle schools in Franklin, and each of those middle schools have at least one literacy and math specialist. So a few of them are here this evening joining me to co-present. So I'd like to ask them to come off mute and say hello and introduce yourselves.
Hello, my name is Jamie Helbig. I am the math specialist at Jefferson Elementary, and I am also a parent of an elementary student at Keller.
Hi, everybody. I'm Brian Kelly. I'm the math specialist representing Parramatta School. Glad to see so many people here.
Hi, everyone. I'm Jen McIntyre, and I'm the elementary math specialist at Keller along with Jen Young.
Hi there, I'm Kristen Ray, and I'm the math specialist at Oak Street School.
Hi everyone, I'm Megan Weiss. I'm the math specialist at Kennedy, and I'm also a parent of a student at Keller.
Excellent. We have one more math specialist, Jennifer Young, who is unable to join us. Oh no, Jen, I see Jen here. Jen, do you want to say hello? She might be having some audio trouble, but we have an incredible team that are in the building supporting teachers and students and administrators every single day in this work. We would not be able to do this all without the support of these individuals. So thank you all for being here to facilitate with me. So the purpose of us having you all here this evening is really to actually have you do some math, just as your kids experience in the classroom. So we're excited to engage in that. We want to share some information about Franklin's K-5 mathematics curriculum resource, which is called Illustrative Mathematics, also shortened to IM to be easier said. So we're going to share some of that information. We'll provide an overview of our process that we've kind of undertaken since last spring, and then provide and gather your input. We're really interested in understanding your child's math experience and in what ways it's going well, and in what ways we can continue to improve. So with that, we're going to just ask for a few norms. So generally, we're going to be asking you tonight to share questions and comments through using the chat feature in Zoom. So at the bottom of your screen, there should be a little bubble that says chat. And so when you click on that and type anything in there, we will see that information and try to respond to your questions. And we'll be asking you to engage in some mathematics through that chat. And then at times, some of the specialists may ask you to come off mute, maybe to share your mathematical thinking and ideas. So we encourage you to click that unmute and share when you want, when appropriate. So with that, I am going to turn it to Jen and Kristen.
Thanks. So all IM lessons start with a warm-up. So let's try one together. So this warm-up is called Which One Doesn't Belong? And this warm-up routine is used in every grade level and connects to the learning in the lesson ahead. So I'm going to ask you to take a minute and study these 4 images on your screen. And then in the chat, you're going to choose which image you think doesn't belong and share why you chose it. I love it. So I see C because it's blue, B because it's a circle, D is a 3D image. Which one I would say A because there are 3 objects instead of 1. I love it. So you can see that all the choices have a reason they don't belong. And just like in the chat, all answers are accepted. The same thing happens in the classroom. All answers are accepted, which provides an entry for all students. It's an invitation for all students to engage and places value in all the students' voices. Tina, can you click to the next one? So here's some other examples of which one doesn't belong. This first one is from a first grade lesson. And it's comparing and contrasting ways to represent quantities, and it prepares students to represent shapes they sort in a way that makes sense to them. So that's a first grade warm up. This is a third grade warm up, and it's from a lesson on multiplication equations where students analyze and compare features of expressions and equations. And then finally, this last one is from a fifth grade lesson on volume. And this particular warm up, it allows students to compare the 4 images, and it gives the teacher an opportunity to hear how the students would use terminology and talk about the characteristics of the items that you see. So, and Kristen's going to take over to show you another warm up.
So the next warm up that we'll do, again, is used K to 5 in every grade level. And you'll see that this is also an opportunity for every student to be invited into the lesson. It's called How Many Do You See and How Do You See Them? So in just a moment, we'll flash an image on the screen. And again, in the chat, if you can jot down how many you see and how you see them. So do you see them in different groups? Do you see them in lines? The first one we're going to take a look at is from a third grade lesson. So we want to flash that image. So these images would be flashed quickly and then would go away. Students would think about how many they saw and how they saw them. So if you want to jot in the chat how many you saw and how you saw them. So I see rows, 40 as 4 groups of 10, 2 times 5, 4 times, again, 4 groups of 10. So, you know, in third grade, students are introduced to the concepts of multiplication and thinking about equal groups. So students may see them in rows of 5. They may see them as groups of 10. Students are familiar with seeing circles in 10 frames. So this is the dots in a 10 frame without the 10 frame. They're familiar with looking at groups of 10. And then we can take a look at a first grade, how many do you see and how do you see them? And again, if you want to jot in the chat real quick, how many you see and how you see them. Sorry, Tina. So here in first grade, we may hear all kinds of things about how they see them. Sometimes they talk about the shapes. But we see 4 corners of a square plus 2 yellow for 6 total, 2 groups of 3, 6 because there are 4 red and 2 yellow. 6 is the same as 4 red plus 2 yellow. So again, you can see students are justifying how many they see and telling us how they see them. It starts it helps students to start to compose and decompose numbers, think about numbers as different parts too. And then we'll take a look at one more warm-up routine. This one is what do you notice and what do you wonder? Some of these images might be repeated in multiple grade levels where students may be looking at the same image in different ways. This one comes from a first grade lesson. But you can see how it could easily be used in third grade or fifth grade. So with a what do you notice and what do you wonder, we ask students to think of something that they notice and something that they wonder. We focus on how students answer this. So we encourage them to answer in complete sentences. I notice or I wonder. So if you want to quickly jot in the chat something that you notice or wonder, and it might sound like I notice that there are certain types of animals, or I wonder how many legs there are altogether. But if you just want to start with what you notice or what you wonder. Great. So again, this is an invitation to the lesson. All students have an entry point, regardless of where they're coming into the math lesson. Any student can notice or wonder. So every student begins the lesson feeling invited to the learning. Back to Jen.
All right, so each of these warm-ups are just some of the examples of the instructional routines in IM. Instructional routines invite all students to engage in the math of the lesson, as we've talked about. They provide opportunities for students to bring their personal experiences as well as their mathematical knowledge to the problems and the discussions. And the routines have a predictable structure, and they flow and follow through the grade levels. So students become familiar with the routines, which provides them structure, and it saves time in the classroom. There are two types of instructional routines. There are warm-up routines, and then there are lesson activity routines. So we've seen some examples of the warm-ups. The warm-ups do one of two things. They either help students get ready for the day's lesson, or they give students an opportunity to strengthen their number sense or their procedural fluency. And then the other types of instructional routines are the lesson activity routines. And these routines are embedded within the tasks of the lessons, and they support the development of student thinking and precision with language. As you can see, that we have quite a few, and the students get familiar with all of them.
Thank you, Jen and Kristen. So now that you've had a little taste of IM, and what students may experience as they get introduced to the math lesson, I just want to give you a little bit of kind of background on, what research is saying and what kind of led us to this place. So the National Council for Teaching Mathematics, known as NCTM, is the largest math organization in the world. It's founded in 1920. And all pre-K through 12 schools across the world look to the research and guidance from NCTM. So along with like their regular publications and other things they do, NCTM has published 21 position statements. And in this, they define a particular problem or an issue that may need to be described or expanded upon. At times, these statements address policy issues, but for our purposes, this particular position paper speaks to having a well-articulated, high-quality, coherent curriculum at a school and district level. It says that it's even more important in the age of open education resources because it is the curriculum that establishes the learning goals in a coherent progression and helps teachers to see and understand the multiple pathways that students take through the progression. And so I kind of tried to bring out and bold that blue language there, because what we want to do in Franklin is provide our students with a coherent progression of learning. So it's very important that the students move from grade to grade, from core instruction to intervention to enrichment, all throughout their educational journey and experience, that those experiences build on one another and are purposeful and in a comprehensive way. And so doing this will prevent these unintentional gaps and redundancies in instruction. And so this is only one pocket of research that we've used from NCTM. We've also pulled from other resources like the Department of Ed. But just to also draw your attention to the comment about the age of open educational resources. So what the internet has provided, it's kind of made our world small, right? We can communicate and connect with so many people, which is so wonderful. And it also has provided education with a plethora of resources that we wouldn't have had otherwise. However, there's some limitations to this in that with open resources, we have access to everything everywhere. And this can lead to curriculum resources that may not be the highest quality that students could be using. It could also lead to inequitable learning opportunities where a student in a second grade classroom may be experiencing a different learning opportunity than a student in another second grade classroom. And with that, there's really no coherence for students without a well-articulated, high-quality, coherent curriculum. So this is why we're one of the reasons we're in the space of utilizing IM in K through 5. And just to kind of piggyback on this coherence, it's important across grade levels. So, horizontally from all second grade classes, all third grade classes. So if a student moves from one elementary school in Franklin to another, they have the same educational opportunity for the same experience. But you can see here in the center column, prior to fall of 2020, students in K to 5, their primary curriculum resource was Envision. It was heavily supplemented and teachers were having to use different resources and kind of seek and find their own. But we did have this vertical alignment in 6 through Algebra 2, where all those students were exposed to the same instructional routines that Jen and Kristen just expanded upon, and the same mathematical experiences. So we really wanted to kind of bring that into a full K through Algebra 2 coherence. And so you can see currently now we have really this nice vertical alignment where the expectations and the student experiences really build upon one another from K all the way through Algebra 2 in a nice coherent way. And so with that, I just want to frame kind of our process, because this isn't just something that, we just decided to implement a new curriculum. There's a lot of thought and research that went into this. So throughout this entire process, we took the time to assess our curriculum landscape. We asked questions like, do teachers have access to high quality standards aligned curriculum materials? Do the curriculum resources help support students at various levels, from those that struggle with certain skills or concepts and to those who need to be challenged and need more advanced opportunities? And so our first step was to say in the spring of 2020, in what ways does our existing curriculum resource align with our portrait of a graduate and align with what the current research is saying? And we found we needed to reevaluate the resources we had in front of kids. And that's referring to the Envision that you saw in red on the last slide. And then we moved into the fall of 2020, which we all know was the hybrid remote learning, not ideal in any way, shape, or form, but we moved to that interesting time when we had actually 23 teachers, which I think is just so incredible. I was not in Franklin in that moment, but that speaks to just the amazing educators that we have here in the Franklin Public Schools. 23 teachers through remote and hybrid learning buckled down and gave it their best and field tested IM in their classrooms. It wasn't easy. It wasn't always pretty. But they really tried to give it their best. And with that, when we got to the end of that point, we said, it's not equitable. It's not fair. It's not right to really not give it another try and roll into the fall of 21 to say, okay, in a more of a normal year, so to speak, where we don't have this hybrid and remote learning, how does IM look in the classroom? Does this support our vision for what we want Franklin students to experience in mathematics? So throughout the fall and the spring of this year, we are supporting teachers with professional development. We're collecting a lot of data to determine the strengths and limitations of IM so that we can make the most informed decision moving forward. So for example, we're looking at what supplemental curriculum tools do we need to embed that may be a limitation within the curriculum. What professional development might we need? What other data tools? You'll see tonight that we actually are going to be asking you to fill out a survey because your voice is extremely important in this process. We'll also be sharing a survey soon with teachers to get their input. So once we collect all of this information and data, we are going to make a well-informed decision in the spring and reflect on what the next steps need to be taken to ensure that the curriculum resource that we have aligns to what current research is saying and to what we feel aligns to our Franklin's portrait of a graduate. And then in the fall in 2020 beyond there, we will continually monitor, adjust, revise, revamp as we kind of move forward. So that's just kind of an overview of our process. And with that, I'm going to turn it to Brian, who's going to kind of bring you through a little bit more specific about how it connects to standards and our portrait of a graduate.
Thanks, Tina. I love that notice and wonder routine, Kristen, because it makes me curious as a learner. And I was just like wondering if you gave the old guy the part about the history of Massachusetts because I'm old, just wondering. So Tina was talking about how our math program is aligned to standards. So the standards she's talking about are the Massachusetts curriculum frameworks. We take our key from the State Department of Education, and they have laid out very clear frameworks, standards of what they would like us to teach. They have clear frameworks for every single grade that so that teachers, students, parents, the community knows what's expected to be learned by the end of the year and what students are able to do by the end of every grade. So those were developed, the most recent ones were developed in 2011. They span from pre-K to grade 12. They were updated in 2017 with feedback from teachers and the community and things like that. And so that's where we take our cues from on what we need to do. The framework has a greater focus on fewer topics you'll see there. So instead of having a mile wide and an inch deep to teach, it's more depth. So it's more depth than breadth is a good way to put it. Another great thing about the new topics is there's more coherence. Within a grade level, we get to see the big picture of math learning as well. So we connect topics like connecting multiplication to things like geometry with area and shapes and things like that. But also we connect learning from grade to grade, and not just from K to 5, but from K to 12, like the counting sequence leads to number topics, and then that leads to like ratios and things like that into the middle school, and that leads to the higher learning in the high school as well. And then another thing that was increased was the rigor with the new standards. And one thing I love about the rigor and talking about that is that it alleviates a lot of fears, I think, that some people have about the standards. So Tina, I don't know if you want to just flash, yeah. So you can think about the rigor as 3 different parts. So we've got the application piece of it, conceptual learning, and the fluency. So the conceptual learning is understanding what the math means, having an understanding behind the math, making sense of mathematical concepts is what that conceptual understanding is. And there's been a big focus on that because that was not always the case in the past. We often followed procedures and didn't really understand why in the past. So that's what the conceptual understanding is. And then that fluency piece, that is the procedure part, being able to perform mathematical procedures fluently. So I just want to assure people that your students still need to be able to add, subtract, multiply, and divide by the time they leave 5th grade, and using the standard algorithm or the traditional method of doing all of those things. So that's an expectation set forth by the state that we follow as well. So because there's some misconception sometimes that that's not part of the standards, and it absolutely is. Just how we get there might be a little bit different than how you remember doing it as a child, but we absolutely positively are getting there. And then the third part, which is so important, is that application piece, is being able to use those mathematical skills to solve problems, which is really the heart of mathematics. So that's like our 3-legged stool that we're always thinking about when we're teaching our lessons and while we were looking at a new math program and things like that. Does it have the conceptual understanding? Does it have that procedural fluency? And does it have the application of problem solving? So that was big for us. So the content standards is one part of the math frameworks. And then another big part is the mathematical practices. And these are a good way to think about these are like habits of mind or things mathematicians do. And this is what we're trying to start with our pre-K students and carries on through right through 12th grade. And these are things that we try to mix into every single day, every single lesson. And the big one I kind of bolded there because it's so important is making sense of problems and persevere in solving them. So that's kind of like the big umbrella, and all the other ideas kind of flow under there. And I won't read them each to you, but we kind of have a different way of phrasing them in the younger grades because these sometimes don't translate really well into kindergarten or 1st grade or things like that. But you can think of these as things like, I never give up when I'm problem solving, I persevere. I can explain my math thinking to other people. I can listen to other people as they explain their math thinking. I can see math in my everyday life around me, and I can use the right tools to solve mathematics. I can look for patterns and structures and use that to help me solve problems. I can look for rules and use those to help me solve problems as well. So it's those kind of big ideas that we try to embed in every single lesson, pre-K to 12, to help build those habits of mind and to help build mathematicians. So that's where we take our cue from the state. And then as a district and as a town, this is kind of how we looked at our portrait of graduate. And I was not on this committee that created this, but it was a community. But I've got to say a shout out to anybody who was, because they did an amazing job at what we expect of a graduate and what we hope to have as a productive student, productive citizen when they graduate from Franklin. And so we looked at these 5 big ideas too, and how they relate to mathematics as well, and how they relate to a mathematic curriculum. And I'll just go through them real quickly because they each have a big paragraph to go with them, but just some of the highlights from them. So we're looking for to have an effective communicator and collaborator, and that's really happening every single day in our program. It's a really student-centered approach where the students are sharing their thinking and their learning, just like with you were doing with Kristen and Jen, how you were always sharing your thinking and learning. The students are doing it orally, they're doing it in writing as well. And creating a confident, self-aware individual and giving them that confidence that they can to be a mathematician, and giving them that confidence that they can share their ideas and share their thinking. And one thing that I think is great is giving them the confidence to make mistakes, and giving them the confidence to realize that if I make a mistake, I can be resilient, I can persevere, and I can grow. So I love that. That's a huge part of the illustrative math program. And being empathetic and productive citizens as they work in groups and they work in teams and they look at things from other people's perspectives is super important. And as a parent myself, this next one was always super important for my own children, was creating curious and creative thinkers. Because if we can allow them to be curious, like that notice and wonder routine, it makes you be curious about things all around you all the time. And that's what's going to make you a lifelong learner. And this program really emphasizes that piece of it, you know, asking the why, asking the how, and being creative about how you go about your problem solving. It's not just following a set of procedures, but it's thinking about things creatively and in a curious manner. So that's really great, the way that just ties in perfect. And then being reflective and an innovative problem solver, and looking at things from multiple perspectives and being able to identify and analyze problems and solve them, because that's what math is. It's a tool that we can use to help solve problems. And so it just all ties in really nicely with that beautiful portrait of a graduate for Franklin.
Thanks, Brian. And as we think about the portrait of a graduate, was really created as a community effort to highlight those skills that students need to be successful beyond 12th grade, right? What do we want them to be able to know and understand and do? And so as it relates to that, we're gonna have a fun moment of participation again. Brian, Jamie, Jen, Kristen, I can't see the chat because I'm sharing my screen, so I'm hoping that you can kind of unmute and share out as folks share. So Forbes published the 10 most valuable skills employers look for. And so I'm going to give you a little bit of background. So there's a link here to it. So in 1970, Fortune 500's most valued skills by employers are here. So I'm going to give you a moment to read through those. So the next set of data or information I want to share with you is what Fortune 500 published, what Forbes published as Fortune 500's most valued skills by employers in 1999. So I'd like you to take a moment and think back to 1999 and write maybe in the chat what you predict some of those top 10 skills to have been.
So we've got communication, creative teamwork, good listener, computer skills, good listener.
Great. And were any of the skills that are listed in the top 10, did those come up again? So I can't see.
Leadership. Going back and forth here.
Okay. All right, I'm gonna show you all. So here we go. So In 1999, you can see there is some overlap. I think one of the biggest biggest skills that it drew my attention to is, writing went from the most valued skill as number 1 to number 10. And that number 2 skill of computation skills no longer appeared on the top 10 list of most valued skills, which is interesting because I think a lot of times in mathematics, we think about those computational skills. And then you have there in number 3, that new skill of the interpersonal skill came into play. And then you have a lot of kind of overlap in 4 through 9 there. So I'm going to ask you one more time. So now here's your 1970 skills, your 1999 skills, and now let's think to 2020. And what do you predict are some of the most valued skills by employers?
Problem solving, critical thinking, creative thinking, interpersonal skills, flexible thinking, communication, technology, teamwork, adaptability, honesty, reliability, technology skills, problem solving, creative thinking, STEM, problem solving, goal setting, listening, perseverance.
I think we're going to see a lot of connections. I think this group should have come up with the top 10 list. So here we go. So a dramatic difference, I would say, certainly from 1970, but also from 1999 on what employers value, the skills that they value. And so what I've done here is I've bolded a few that I think, as Kristen and Jamie and Jen and Brian have been speaking and talking throughout this entire presentation, a lot of these skills are what's embedded not only as what we hold value to in Franklin and in our portrait of a graduate, but certainly in the pillars in which IM has been built on. And so we're really trying to embed these complex problem-solving situations and having students think creatively, think outside the box, give them the permission to make mistakes that has come up tonight. I probably should have bolded creativity, because like thinking about things from different perspectives and in different ways, certainly coordinating with others. I mean, every single day, students are collaborating with one another, talking with one another. That is most of the time after they've done some of their own personal thinking and doing. And this judgment and decision-making, when Brian was talking about those math practices, that critiquing the reasoning of others comes into play quite a bit in our mathematics classrooms. So just wanted to highlight those. It's just another connection as to why we have decided to pursue illustrative mathematics as our tier 1 core curriculum and bring that through not only K through 5, but all of these routines that the specialists have been talking about also carry through the middle school as well. With that, I'm going to turn it to you, Jamie. And so we can talk a little bit about what this looks like in the classroom. Most exciting part.
So I'm going to talk a little bit about what it would look like in your child's classroom. If you could go to the next slide. Students learn math by doing math, not by watching somebody else do math. I think back to the way some of the experiences that I had as an elementary student, and I remember watching my teacher solve problems. I remember doing exactly what the teacher did, and I remember mimicking that thinking over and over and over again. And that is not what we see in our math classrooms in this curriculum. It is very common in a lesson to see our students presenting to their peers in a small group, as you can see in the picture on the right, and presenting to their classmates on the board on our touch views that we have. So on the left, you see a student here that has participated in a card sort, and she's justifying her thinking. She's sharing with her peers why she has created these categories, why these cards fit into these categories. And after this, there was about 4 or 5 other students that came up that had a different way of thinking and a different card sort that they shared with their peers. And everybody kind of looks at it a little bit differently, and they're all practicing giving their reasoning why and justifying the math that they have done. And throughout this experience, the teacher's highlighting some of the concepts that are going to be appearing in their upcoming unit. In the middle picture, you see one of our upper elementary students here that is multiplying a fraction by a fraction. And that's just something I remember learning a procedure and then following it a bunch of times, but never really wondering why you ended up with the answer that you got. So we have a student here that is modeling what it looks like to multiply 3/4 times 4/5 and why I'm ending up with 20ths at the end through a visual. And with our younger students here, we have a counting collection that this student has sorted in a particular way, and they're kind of walking their peers through their organization and how they can tell how many they have inside their collection. So all of these kids here are doing math. They're presenting their thinking to their peers. And this is a problem-based curriculum. So students are learning these concepts as a result of solving these problems. They're not learning the concepts and then solving the problems. They're kind of doing it the opposite way. So they're approached with a task, they're bringing their background knowledge, they're working with their peers, and then they're working on figuring out the concepts and having the concepts and procedures explained to them as they're engaging in these tasks. If you could go to the next slide. Students have collaborative and independent work activities with manipulatives and models. So the activities that we participated in earlier would have happened at the very beginning of a math lesson. So students are having a whole class discussion with a notice and wonder or with a which one doesn't belong. And what would follow that would be activities. They usually have 2 or 3 activities within a lesson, and they're very collaborative in nature. So at that point in time, students would break off and work with their peers. So you can see here, we have some students on the left that were 3rd grade students. They're working on creating a space with a particular square footage. You know, they're not told how to do that. They're just told that you need to create a rectangle that has this square footage. So they have to kind of work with the tools that they have available to them and see if they can figure out what dimensions they may want this rectangle to have so that they would have this square footage. They're also kind of building a sense of how big a square foot really is, which can help them in estimating situations because they've had that concrete experience with that. We have some of our younger learners here that are representing quantities in different ways and practicing with the concept of addition through putting parts together. So you can see that the kids are working together. While this is happening, the educators in the room would be walking around and monitoring all of the conversations that they're hearing and all of the different strategies that they're seeing, because we're looking to see which strategies and which students we can highlight, like we had in the first slide where we had the students at the front of the room really facilitating the conversation. We're selectively looking for which students we want to highlight and kind of share their thinking based on what we saw in the classroom for the student-led strategies. So I might not have a particular strategy in mind. We're going to be working off of what we see in the classroom. And then there's an opportunity within the lesson for a synthesis as well. So if there are important concepts that maybe we didn't see occur in any of our collaborative groups, we have an opportunity to really bring that out as well as students are learning these concepts. But they've really been the driving force behind the conversations that we're having and the learning that's taking place during the lesson. And there's one more picture here. With our student-centered lesson structures, a lot of these lessons really encourage risk-taking and perseverance, and that productive struggle, which we talk about a lot. Discourse is very important as they're working with their peers and communicating and having discussions about their strategies. I know one of our favorite pictures that we spoke at length about is the one with the students and the cards and the counters. That was a lesson that was run with Kristen at her school. And, you know, these students were approached with a pretty rigorous task. And they had to come up with a way that they could keep track of what was happening in the situation so that they could come up with a solution. Nobody told these students to take out cards and to take out counters. That was something that they came up with on their own so that they could model what was happening in this problem. And by not giving up, by being creative, by problem solving and being collaborative, they were able to come up with a solution. And maybe there were other groups that weren't able to, but we can highlight the strategies that were used here. And I don't have to tell the students what to do. They can learn it from their peers, which is just so much more powerful. And then we have some other students just engaging in tasks together with their classmates as well. And then if you go to the next slide, I know that oftentimes parents will say, I might be seeing something and it doesn't look like what's familiar to me, and it's not the way I learned it. And that can be a really uncomfortable feeling as a parent, to feel like your child has an assignment and they might need a little bit of help with it, and you're not sure what they're doing or how they're solving the problem, just because it may be a little bit different from the way that we learned or that you learned in your past experiences. It is important for kids to struggle in a productive manner. So it's okay if they're working on a task and it's difficult for them, because those are important skills and those are things that we have to experience so that we can take the information that we do know and work on trying different things and not giving up. If we're never in a situation where we are struggling, we're not going to learn those skills. So from the parent side, when you're trying to assist, asking questions to elicit more thinking and keeping the ownership of that thinking on the children is really important. So some possible questions that you can ask is just something like, what do you know about this already? Did you have a problem that reminded you of this that you worked on in class? Tell me more about your thinking. What could you do? Not what should you do? A big difference between what should you do versus what could you do. So when I open it up to what could you do, there may be more than one thing. There's not one right way that I can solve the problem. Just be curious about what you're seeing. You can always reach out to the math specialists at all of the buildings, to the classroom teachers, if you'd like a little bit more information on some of the different ways you may be seeing it, but coming from a place of curiosity and always staying positive, because the disposition or the mindset that kids have about themselves as mathematicians is really important. And although you might think that it's difficult and it may not be your favorite subject, those would probably be things that you may want to keep as inside thoughts, just so that the kids can always stay really positive. We are all math people, and the kids, when they come with a positive mindset about math, it just really helps them with some of the other skills that they're working on. And one of the things that's not up there, but I think is always important, is to just highlight some of the math that already happens in your everyday lives. So, things like time management, or you have an activity you need to get to, what time should we leave so we have enough time to get there, or elapsed time, budgeting at the grocery store, baking. There's lots of opportunities at home that you can just kind of highlight the math that's already going on.
Thanks, Jamie. So with that, we are drawing to an end, and we want to thank you for joining us. I think, as you can see from the presentation and everyone sharing tonight, we have an incredible passion for mathematics and developing our students as mathematical and creative thinkers. I cannot commend this group of 5 individuals you see on the screen for the incredible work that they do in supporting the teachers and students and administrators every single day in the building. And when Jamie said, please reach out, they mean it. I do as well. Please reach out. My contact information is there as questions arise. I know we've kind of given a lot of information. We will share these slides as well. And just want to know that we're here to support you. We are here to support your students, your children. as they progress through the Franklin Public Schools. I couldn't be prouder to be part of the Franklin Public Schools, and I'm excited about where we're going next. With that, we really, really would love your input. And so Jen is putting in the chat. I might stop sharing in the moment so I can see. So Jen is going to put in the chat a link to a Google form. And we're just asking a few short questions so that you can provide us some information as we work to create a K-5 instructional vision that will continue to guide this work. And also as we kind of work to understand the strengths and limitations of what we're doing and how we can continue to improve and support you and your students every day. So with that, I thank you so much for taking the time to join us. We are ending a few minutes early, which is never a bad thing, but please feel free to reach out to any of us with any questions or concerns that you have throughout the year. Have a good night, everyone.